Okay, so here's the start of our lab here. So I have my little lab notebook here that I'm going to be checking off as I do each step, okay? The first thing is that I have to prepare a boiling water, okay? So if I look here, you'll notice that I already have something in here before I add water. These are called marble chips. We call them boiling chips because we use them to help us boil our water faster. So water has a really hard time, this one sprays everywhere. Water has a really hard time boiling if there's nothing that it can like scratch up against, okay? So adding the boiling chips helps create friction, which creates energy, which helps us boil our water faster, okay? So that's what I'm putting in here. Make sure that all of that's set up, turn it on. So here's my boiling water, so I'm gonna check that off. Okay, next thing is I'm going to label 5 weighing dishes with my substances, okay? So my first substance is silicon dioxide, okay? So I'm gonna put that here. I have sodium chloride, which is NaCl. You see what I'm doing is I'm labeling the bottom of them. And I wanna label them before I weigh them because this ink has mass to it, okay? The next one I'm gonna do is stearic acid. So stearic acid is right here. And then I have sucrose right here. And then the last one I have is aluminum, which is a metal, so that one's right here. Okay, so let's start weighing these out. Now normally I would give you different stimulas for each substance, okay, but in this case I don't have that. So what we're gonna do now is I'm gonna bring you over here to the scale. Okay, now this lab is not qualitative, and what that means is we don't really care about the mass of the substance because we're ultimately just testing their physical properties. So I don't have to record any of these masses because I'm not gonna do anything with these numbers, okay? But it's important that we don't wanna use too much chemical because chemicals are expensive. So the first thing we're gonna do is you see my scale here, okay, and you see I have nothing on it, and it's 0.07. So the first thing I'm gonna do is there's a cover to it. So I'm gonna pull this cover up, okay? And I'm gonna tell the scale that I want it to go to 0. So what I'm gonna do is I'm gonna hit the 0 button, and it goes to 0, okay? The next thing I'm gonna do is I'm gonna take my aluminum weigh boat, and I'm gonna put it onto the scale. And you'll notice that it gives me a number, right? Because that weigh boat weighs something. I'm gonna tell my scale again that I want it to pretend that nothing's there. So I'm gonna hit 0 again, and I'm gonna come in here with my aluminum, and I'm gonna cut a little bit off. Oops. I'm gonna put it in there. Give us a little bit more here. Okay. So there is my aluminum. Okay, and I'm gonna do the same thing for every single one. Okay, so I'm gonna put aluminum here. Next one I have is sucrose, so I'm gonna put the weigh boat on there. And just like I did before, I have to tell the scale that I want you to pretend like nothing's there. So I'm gonna hit 0, and then I'm gonna use my scupula here, and I'm gonna weigh out some sucrose. Okay, just put a little bit more on there. Just a little bit more. Okay, there we go. There's sucrose, set that off to the side. I'm gonna do the same thing. Here's NaCl, so I'm gonna put it on there. I'm gonna tell my weigh boat, please pretend that it's not there. So we're gonna 0. We're gonna do the same thing here. Get some sodium chloride. Whoops, that's way too much. Much better. Okay, so there's our sodium chloride. All right, do the same thing, stearic acid. So I'm gonna put it on here. 0. Do the same thing. Okay, that's good. All right, and then the last one that we're gonna do is silicon dioxide, which is just sand. Okay, so here's silicon dioxide. Tell my scale 0. Do the same thing. You'll notice that it looks like sand because it is sand. Way too much. That's fine. Okay, because I have plenty of sand. All right, so there we've weighed them. Okay, the next part of the lab is we are going to test and record the physical properties and see if there's any odor or volatility to any of these substances. Okay, so the first one I'm going to do is aluminum. So I'm going to take it and I'm going to waft. So aluminum doesn't really have any odor to it, but if we look at it, it's shiny, it's really hard, okay? The next one I'm looking at is silicon dioxide. All right, I want to make sure that you can see these. I'm not too close. Yeah, silicon dioxide. So here's silicon dioxide. Like I said, silicon dioxide is sand. Okay, so it has like different pieces in it. You can kind of tell. It's grainy. It has no smell to it, no odor, and it's not volatile. The next one I'm doing is sucrose. Sucrose looks like sugar. Okay, so also a solid, white. Not really getting any volatility from it, but it does smell sweet. Okay, this is stearic acid. Stearic acid is also white, but the chunks you'll notice are a little bit bigger. Okay, no volatility. Really no smell either. And then the next one is sodium chloride. Also a white solid. I probably wouldn't be able to tell the difference between sodium chloride and sucrose. No smell. Okay, so there's that. Okay, the next thing we're going to test is whether it conducts electricity or not. And I'm going to tell you right now, just because my voltmeter is kind of moving too much, if I connect a little piece of aluminum here, okay, so if I put aluminum on here like this, you'll notice that my voltmeter will start reading, okay? Oh, I'm on the wrong one. Oh, there it goes. So it goes up to 0.47. So since there's movement on the volt reader, that indicates that aluminum conducts electricity. Okay, now we're gonna look at whether these dissolve in water or not, okay? So I have went ahead and put each substance into the well plates, okay? And I did it in order of what it is in my data table. So I did aluminum, silicon dioxide, sodium chloride, stearic acid, and sucrose. And the next step here is we need to see if it dissolves in water. So I'm gonna add a little bit of water to each one of these. And then I'm gonna make observations. And then I'm gonna have to stir them a little bit here. Okay, now noticeably, we see 3 of them did not dissolve. So aluminum did not dissolve in water, silicon dioxide, which is sand, did not dissolve in water. My sodium chloride did dissolve in water, stearic acid did not dissolve in water, and then my sucrose also dissolved in water. So go ahead and take a second to record those. Okay, next thing I'm gonna do is I'm gonna test the ones that did dissolve, I'm gonna test whether they have a current or not. So I'm gonna bring this guy here. Okay, so the first one I'm gonna put it in is sodium chloride. Yep, we see movement, so that means it conducts electricity. I don't know where the oxygen gas came from. Okay, and then I'm in sucrose. No movement, it's staying in the same spot. So the only one that conducts electricity when dissolved in water is sodium chloride. Okay, what I'm gonna do next now is I had to come over to the fume hood. This is the fume hood, right? And you'll notice that it has a bunch of chemicals in it, and these are all chemicals that are considered volatile. So instead of letting the stuff come into the air, it takes it outside. Okay, so I'm gonna open this up. I have them ordered how they are in my data sheet, and I'm just gonna add drops of hexane to each one, and then we're going to make observations. Okay? So hexane, 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 hexane. Okay? So there's that. I'm going to stir them up, and then we'll make some observations here. Okay, so let's look at each of one of these, all right? So aluminum doesn't look like there's much difference, okay? No dissolving. Now, silicon dioxide, you can still see some of the solid, if it clears up. You can still see some of the solid in here. Okay, but there's not as much as there was when we originally started. So I would say silicon dioxide dissolved in the hexane. If we look in here, I still have some solid in my sodium chloride, so no dissolving. This is sucrose. Also still see solid, no dissolving. And then I still see stearic acid in here. However, it's starting to dissolve, okay? Like it doesn't, I don't have as many chunks in here as I originally started with. So we're gonna say that stearic acid is dissolving in hexane. Okay, so that's what you're gonna record there. Okay, now for this step, what I've done is you'll notice, I'm gonna put the watch glass on here now, but you'll see that they're starting to become steam off of the water. Okay, so let's think about this for a second. Water can only boil at 100 degrees Celsius, okay? So if anything melts on the watch glass when I put it over the boiling water, that indicates that that substance's melting point is either 100 degrees Celsius or less. Okay, anything over 100 degrees Celsius melting point will not melt. Okay, so I'm gonna put this on here. Okay, and you can see, so aluminum, silicon dioxide, sodium chloride, stearic acid, and sucrose. Okay, so let's give that a second to see what happens here. If any of them will melt. So you see the condensation collecting on the top, so let's just give it a few more minutes here. That's the thing with labs. So if you're doing this lab, this video is probably gonna only be about 20 minutes long, right? I was able to do it pretty quickly, but that's because I've done this before. Typically when we do labs, they do take the whole bell. Okay, so we need to make sure that we're paying attention to whether it's actually melting or if it's just the condensation on the watch glass. So let's let it refocus here. Why isn't it refocusing? Okay, there we go. So far, nothing looks like it's melting. Now it's starting to be really hard to see the sucrose and the sodium chloride, but I'll keep an eye on them for you. Okay, you can kind of see stearic acid is looking a little misty here. Like it's looking like it's doing something. Yeah, there it goes. You see it? Do you see the liquid forming around the stearic acid? That looks like that's the only thing that's sort of like turning into a liquid. Yep, there it goes. Okay, so it looks like stearic acid is the only one that has a melting point of around 100 degrees Celsius or lower. Okay, now the last thing, well, not the last thing, I gotta test the brittleness as well. The last thing I'm gonna do is light a Bunsen burner here, and we're gonna see if the other solids will dissolve. Okay, so there's my Bunsen burner. So first what I'm gonna do is silicon dioxide, so I'm gonna hold it over the heat. And if it melts, it should melt pretty quickly. So I'm not getting any melting from silicon dioxide here. No melting. Put that one to the side. This is sodium chloride. Again, no melting there. And then I'm not doing aluminum because I know aluminum's not going to melt because aluminum's a really hard metal. So the last one I'm going to test is sucrose. Instantly starts melting. Instantly. Look, there we go. You see that? So sucrose boils or melts, okay? So there's that. Now it smells like burnt marshmallows in here. Okay, so now I'm gonna test the brittleness. So I have a mortar and pestle here. I'm gonna start with aluminum. Nothing, okay? So not brittle. Silicon dioxide next. Yeah, easily grindable. Okay, so super brittle. Next one is sodium chloride. Yep, again, turns it into a powder, so sodium chloride's brittle. Next one's stearic acid. Also, instantly goes into a powder, so brittle. And then the last one, you've heard of powdered sugar. Sucrose, yep, absolutely brittle, okay? So there's all your data. Thank you.